Welcome back to the Math Professors. On this channel, we provide free content that covers really most of all college mathematics. So today what I'm going to do is I'm going to cover something that I find interesting in Calc 2. It's one of my favorite u-substitutions. So if you like our free content and you want to help us build our channel, consider liking, subscribing, and sharing. So let's get into it. So what I want to do is I want to evaluate this integral of x to the 2x times the quantity natural log of x plus 1 dx. So this is a u-substitution, so really what we're going to need is we're going to need to know what a u is and then eventually what a du is. So I have to make our substitutions, u and du. So here's kind of the trick is u is going to be equal to this x to the 2x. So if I want to find, this thing's differential, I'm going to have to take really kind of its derivative. But what we have is we have a function that is of, two families. I have a base that is a variable, which seems very polynomial in nature. And I have an exponent that's a variable, which is very exponential in nature. So really this is kind of stuck between two families of polynomials and exponentials. So in order to do this, what I need to do is I need to get out of those two families and turn it just to a single family. So I really want to take this exponent and put it out front, and we know that the superpower of logarithms allow us to do that. So in order to find du, we're going to have to start out with this natural log of u is going to be equal to the natural log of x to the 2x. Again, what that allows me to do is pull that 2x out front, so this is going to be 2x times the natural log of x. Okay, now I can take its derivative and then eventually find its differential. So this is now an implicit equation, so I have to take the derivative of this side, the derivative of this side, but when I take the derivative of a function of u, we know that u is actually a function of x, so I have to follow it by du dx. So the derivative of the natural log of u is going to be 1 over u, using the chain rule is going to be du dx. Now over here I have a product, so I'm going to have to use the product rule, so the derivative of the first, times the second, plus the first, times the derivative of the second. And then, simplifying this as much as I can, this is going to be equal to 2 natural log of x plus just 2. All right, so now I'm really trying to isolate, this du essentially. So I'm going to have to put the u to the other side. So du is going to be equal, or dx is going to be equal to u times that expression. And I know that u is equal to this function. So this is going to be equal to x to the 2x times 2 natural log of x plus 2. And that's going to be du dx. So finally, du is going to be equal to x to the 2x times, I'm going to factor out this 2, and then you guys will see in a minute here why. Okay, so what we're trying to do is we're trying to make substitutions, and when I look at the original expression, what I can see is I have x to the 2x times the natural log of x plus 1 dx. Oops, I throw it by dx. And over here, I have almost all of that, except for this pesky 2. So dividing both sides by 2, I can have 1/2 du is going to be equal to x to the 2x times the natural log of x plus 1 dx. So in this case, actually, this right-hand equation for your differential actually gives you the entire expression. So this is nothing more, this thing is nothing more than the integral of 1/2 du. So making our substitution, this is the integral of 1/2 du. This entire thing is equal to this, which is 1/2 du. Now I can integrate it. So the integral of 1/2 du, I can pull out the constant, so I can say that this is, 1/2 u plus c, where u is equal to, finally using this equation, this is 1/2 times x to the 2x plus c. So that is why I like this. What I really enjoy about this particular example is that you have to use natural logs and then take its derivative implicitly. It's really clever. All right, so again, thank you for watching, and please consider liking, subscribing, and sharing.